large dark areas on the surface of our star. Astronomers have long known that sunspots are regions where magnetic fields become concentrated. Yet anyone who played with magnets as a child has felt how magnetic fields of like polarities repel each other. Likewise, the strong magnetic fields of sunspots should naturally repel each other too, causing the sunspot to quickly dissipate. Indeed, observations show that surface material clearly flows out of the spot. What then makes sunspots so long-lasting? How do they remain intact for weeks and months? A team of scientists had to look beneath the surface of the sun to find the answer. Alexander Kosovichev and Junwei Zhao of Stanford University, along with Thomas Duvall of NASA's Goddard Space Flight Center, used MIDI's unique ability to probe the happenings just below a sunspot surface, and for the first time, they have clearly observed inward-flowing material. We discovered that the outflowing material is just a surface feature, said Zhao. If you can look a bit deeper, you find material rushing inward, like planet-sized whirlpools or hurricanes. This inflow pulls the magnetic fields together. The cool downward flows dissipate at the same depth where the hot upward flows diverge, explained Duvall. With these data, one cannot get a sharp enough picture to really explain the details. Until now, we've looked down at the top of sunspots like we might look down at the leaves and treetops. For the first time, we're able to observe the branches and trunk of the tree that give it structure. The roots of the tree, however, remain a mystery.
That's for you guys. Now, so they started to see now that the sunspot, which some of them are like 14 times the size of the Earth, okay, are huge vortices going towards the middle. And when they talk about material being spit out of the sunspot, you guys know what material that is? Water. Large amount of water comes out of sunspots on the sun, right beside the fire.
Is that their conclusion?
No, that's measurements. Pardon me?
Is that their conclusion?
That's their measurements of the material that's coming out, mostly water. Well, steam, you know, H2O. Yeah, it's spectroscopy. But then, you know, so then I was thinking about that. I'm like, okay, well, you know, if you were to travel through the universe, and everything in the universe is a singularity, then you could, you know, build a ship that's able to go inside a singularity. That ship would have to have a drive at its center that's a singularity itself. Okay? And you could enter a local singularity, and because you're in singularity, connected to all things, you could come out anywhere you want, anywhere else in the universe. And you could actually follow a linear progression of that travel. Although it would only take seconds for you to go across the galaxy, you would still go through the singularity of the sun, through the singularity of the hub, and then out to another singularity that would be a solar system in some other corners of the galaxy. You could even go from the hub to another galaxy hub and then come out wherever you want there. You guys are following this?
Yeah.
Okay. Now, if you think of it this way, then it's like, okay, well, we should be able to see these guys coming in and out. So I started to investigate this, and I found something very bizarre. I found that most of the telescope and probes that observe the sun are owned by no one else but the Vatican. The Vatican. And I was thinking, well, that is strange. What does the Vatican want with the sun? And I noticed, so I started to, kind of keep track of what was going on the sun. And I kept on downloading, material from NASA, from the SOHO probe, which is a probe that's orbiting the sun. And one day, this video was put on the net. This was a while ago, almost 5 years ago now. There's been many others since then. This is a good one. Let's take a look at it. They placed this on the sun. Now this is the probe telemetry. This is the camera. And it has a little arm that has a protective lens because otherwise the electronics would get overwhelmed. And this is the sun surface here. This is a representation of the sun surface. And this is the video. So this video was placed on the net saying comets, sun-gazing comet hits the sun. And a bunch of people downloaded this stuff. And, emailed NASA and said, what are these objects? Because comets usually have extremely long tails when they approach an object like the sun. Do you know how big these objects are? At least the size of the Earth. Okay? A comet the size of the Earth orbiting the sun or approaching the sun should have a very large tail, very visible tail. So, after a whole bunch of astrophysicists emailed NASA going, what are these objects you're calling comets? They retracted the video. And I was lucky to get a copy because after, a whole bunch of people complained when they retracted the video, they put the video back on. But all of a sudden, the objects had tails. However, let's go back and analyze this video a little bit. You can see the stars in the background all going from left to right. Okay, that's because the probe is orbiting. Right? And then you can see all these little white dots. Those are particles hitting the camera. Let's try to find one. You see this one? That's a particle from the sun hitting the camera. So you can ignore these little bleeps. But if you actually go backwards, you will find that there is only one object going towards the sun at first. And then at this frame, you will find two little objects here that appear that in the next frame move from here to here. Can everybody see this?
Not the light.
Oh, the light.
Oh, no, it's better.
So, from here to there. Right? Now, that's against all the other movements in the background. Okay? And then on the next frame, these two objects become one. Now, that's quite possible if the two objects ended up one behind each other, right? So now it becomes one to an observer here. And then the next frame, these two objects become the second comet, which makes a 90-degree angle turn. See? Boom, become one, and then starts moving in this direction. So it came from here, it became one here, and then started moving in a completely 90-degree angle direction from where it was going. Now, the only comets that I know of that do that type of crazy movements are the ones that have little windows and little guys in the back waving. Okay?